By 1943, the tide of the Pacific War had unequivocally turned against the Japanese Empire. The vaunted Mitsubishi Zero, once the undisputed master of the Asian skies, was now an obsolete liability against newer Allied fighters. Japan desperately required a successor, an aircraft that could match the speed and firepower of the incoming American designs. They needed a fighter that could restore the belief in Japanese aerial supremacy and halt the inexorable Allied advance. The answer arrived in the form of the Nakajima Kyo-84 or Gale, a fighter so promising it was given the Allied code name Frank. This aircraft was conceived as a truly universal fighter, capable of dogfighting, diving, and long-range escort. Its designers sought to combine the maneuverability and climbing speed of earlier Japanese fighters with the protection and hitting power of their Western counterparts. The specifications demanded a speed of over 400 miles per hour and powerful armament, a combination previously thought impossible in a Japanese design. High hopes were placed upon this single aircraft to change the strategic balance in a war that was already becoming a grim fight for survival. Initial production models hinted at a true masterpiece, a formidable opponent that Allied pilots had yet to encounter. The Kyo-84 was believed to be the technological trump card that would allow Japan to finally secure its defensive perimeter. It represented a last, great gamble on the genius of Japanese engineering to overcome the enormous resource gap. This new machine was briefly the embodiment of Japan's desperate faith that technology could win the war. The Kyo-84 was an aircraft of exceptional, almost contradictory, design characteristics. It was powered by the enormous and complex 1,900 horsepower Nakajima Hard 45 Homa radial engine, one of the most powerful engines ever built in Japan. This engine provided the speed that was utterly lacking in the Zero and other early war designs. The fighter's wings were heavily loaded, providing high-speed performance while still incorporating sophisticated Fowler-type flaps for superior low-speed maneuverability. It featured a streamlined canopy and an overall clean aerodynamic profile, which contributed to its impressive top speed. For pilot protection, the Kyo-84 finally introduced self-sealing fuel tanks and a thick armor plate behind the pilot's seat. This was a major concession by Japanese designers, who traditionally prioritized lightness over pilot survival. Its armament was also significantly upgraded, typically featuring two 20mm cannons and two 12.7mm machine guns, giving it formidable punching power. In the hands of a skilled and well-trained pilot, a fully operational Kyo-84 was arguably a match for any Allied fighter in the world in 1944. American test pilots who flew captured examples after the war praised its excellent handling and responsiveness at all speeds. It had the raw power and structural strength to compete in the fast-paced, high-altitude arena of modern aerial combat. The H-8 truly represented the pinnacle of wartime Japanese piston-engine fighter development. When the Kyo-84 first entered combat service in early 1944, its performance was immediately a shock to Allied forces. It was first deployed in the fierce air battles over China and later the Philippines, where it scored impressive victories. Allied pilots, accustomed to engaging relatively slow and lightly protected Zeros, were suddenly faced with a true speed demon. Reports from American and British aircrews quickly noted the Kyo-84's incredible speed in a dive and its powerful rate of climb. Japanese pilots felt an immediate confidence boost in their new machine, recognizing its qualitative superiority over their older types. They could now choose when and how to engage, no longer simply trying to avoid contact with the faster Allied planes. One of its most famous early deployments was with the 22nd Fighter Group in the Philippines during the Battle of Leyte Gulf. In these engagements, the Kil-84 proved capable of challenging the best American fighters, including the P-38 Lightning and the F-6F Hellcat. The sheer speed of the Hay-8 allowed pilots to execute devastating hit-and-run attacks against bomber formations. For a brief, shining period, the Kil-84 was the aircraft that lived up to its designer's grandest ambitions. Its initial combat record suggested that Japan had finally developed a machine to turn the air war back in their favor. The Allied forces were forced to revise their tactics and acknowledge the arrival of a dangerous and modern opponent. The promising early performance of the Kil-84 was tragically undermined by the catastrophic collapse of the Japanese industrial base. As the war progressed, intense American bombing campaigns systematically destroyed key factories and supply lines. This meant the mass-produced Honots that reached the squadrons were often drastically inferior to the pristine test models. Quality control plummeted as manufacturers struggled with raw material shortages and the use of poorly trained, substitute laborious. Essential materials like high-strength aluminum alloys and precision steel became scarce, forcing the use of inferior substitutes. Many Ki-84s rolled off the assembly line with improperly heat-treated landing gear struts, leading to frequent collapses on takeoff and landing. The critical fuel and oil lines were often made of low-quality materials that quickly cracked or failed under operational stress. This meant many aircraft were already compromised before they ever reached their operational airfields. Simple items like instrumentation and radios often failed entirely or were not installed at all in the late production planes. Pilots were handed fighters that looked formidable but were fundamentally flawed beneath their camouflage paint. The brilliance of the Ki-84's design was effectively sabotaged by the crumbling infrastructure meant to manufacture it. Japanese industry could design a world-class fighter, but by 1944, it could no longer reliably build one. The heart of the Ki-84's power, the Nakajima Hard 45 Homar engine, also became its most crippling weakness. The Homar was a complex, highly stressed 18-cylinder radial designed to maximize power output from a relatively small displacement. This complexity required extremely tight manufacturing tolerances and the highest quality components to run reliably. The collapsing industrial base simply could not meet these demands for precision engineering. As a result, engines suffered from chronic overheating, cylinder failures, and frequent loss of power in combat. The magneto and ignition systems were notoriously temperamental, often failing to start or cutting out during critical phases of flight. Maintenance crews on forward bases, themselves lacking proper tools and spare parts, struggled mightily to keep the Homar running. It was a nightmare of fouled spark plugs, cracked collector rings, and persistent oil leaks that could not be solved. The engine's reliability was further degraded by the use of low-octane fuel and poor-quality lubricating oil, all that Japan could still provide. What was designed as a revolutionary powerhouse became a maintenance black hole that grounded a massive portion of the Ki-84 fleet. A common joke among Japanese ground crews was that the Hay-8 was a beautiful fighter, but its engine was made of glass. Its failure to sustain consistent power turned the Ki-84 from a potential war winner into a frustrating garage queen. The operational serviceability of the Ki-84 was fundamentally tied to the complete breakdown of Japan's logistical supply chain. By 1945, the vast distances of the Pacific and constant Allied submarine warfare had severed the Empire's lifeline. Spare parts for the Ki-84, already scarce due to production issues, simply could not reach the forward airfields where they were needed. A damaged wing, a busted hydraulic line, or a worn propeller governor could permanently ground a fighter due to a lack of simple components. The pilots and mechanics often resorted to cannibalizing damaged or derelict aircraft to keep a single fighter flying. This vicious cycle of cannibalization further reduced the total number of available Ki-84s across the theaters. Crucial aviation-grade gasoline and specialized lubricants were almost impossible to deliver to the front lines. The poor quality of the fuel severely limited the performance of the HOMAR engine, forcing pilots to fly at lower power settings. This dramatically reduced the He-8's speed and altitude advantage, eliminating its primary combat edge. Airfields themselves were constantly under attack, damaging runways and destroying precious stores of fuel and ammunition. The lack of infrastructure and supplies meant that for every Ki-84 in the air, several were sitting immobile on the ground. The best fighter Japan ever produced was defeated not just in the air, but also by the simple reality of logistics and exhaustion. As the Ki-84 struggled with its internal demons, a new and devastating American fighter arrived in force, the P-51 Mustang. The Mustang, powered by the incredible Rolls-Royce Merlin engine, was a machine engineered for speed, altitude, and range. It represented a significant leap in Allied fighter design, far outpacing the obsolescence of earlier American types. The P-51 was initially deployed to the European theater but soon made its mark in the Pacific as the war drew closer to the Japanese homeland. Its laminar flow wing design allowed it to achieve exceptional speeds, making it one of the fastest piston-engine fighters of the war. Crucially, the Mustang possessed a formidable combat radius, thanks to its internal capacity and use of external drop tanks. This incredible range meant that, for the first time, American bombers flying missions to the Japanese mainland could be escorted all the way. No longer could Japanese interceptors simply wait for the moment the short-legged escorts turned back to base. The arrival of the P-51 completely changed the strategic balance of air power over the vast expanse of the Pacific Ocean. It was a reliable, well-built, and highly capable platform designed for the punishing realities of long-duration, high-altitude flight. The Mustang's arrival signaled the end of any remaining hopes for the Japanese to regain air superiority. The critical difference between the P-51 Mustang and the Ki-84 He-8 was most pronounced at high altitude. The Ki-84's Nakajima HOMAR engine was fitted with a 2-speed supercharger, but its performance dropped off dramatically above 25,000 feet. This limitation was compounded by the consistent poor quality of Japanese fuel and the engine's inherent unreliability at altitude. The P-51, however, was explicitly designed for the high-altitude fighting required for bomber escort over Europe. Its American-built Packard V-1650 engine, a licensed version of the Merlin, performed optimally at the rarefied air of 30,000 feet and above. This allowed the Mustang pilots to dictate the terms of engagement, always possessing the crucial advantage of height. They could swoop down on Japanese interceptors with a massive energy advantage, making them nearly impossible to counter. The P-51 also offered superior cockpit pressurization and heating, allowing its pilots to remain fresh during long, cold escort missions. Mustang pilots often reported that the struggling Japanese fighters, including the Ki-84, could not even reach their cruising altitude. The Ki-84's vulnerability at high altitude was a fatal flaw against the B-29 Superfortress raids on the Japanese home islands. The P-51 could easily escort the bombers to their targets, fighting off the desperate interceptors from an advantageous position. In the rare instances where a perfectly maintained P-84 met a P-51 Mustang on equal terms, the resulting combat was legendary. A well-tuned Hay-8 with a fresh engine and a skilled pilot could exploit its superior turning radius to outmaneuver the Mustang. The P-84's ailerons were incredibly light and responsive, giving it a fleeting advantage in a close-in, horizontal dogfight. However, the P-51 pilot was trained to never let the fight descend into the P-84's preferred turning environment. The American strategy was simple: use the Mustang's superior speed and diving ability to engage and disengage at will. They would dive down, fire a burst of their 6.50 caliber machine guns, and immediately climb back to altitude, refusing to turn with the frank. This boom and zoom tactic negated the P-84's agility advantage and exploited its poorer high-altitude performance. The Mustang was also structurally more robust and could absorb far more battle damage than its Japanese counterpart. Even if hit, the P-51 often had the structural integrity and reliable engine to bring its pilot safely home. While the P-84 was a superb design, its combat effectiveness was entirely dependent on conditions that Japan could no longer provide. The duel became less about the theoretical capabilities of the two aircraft and more about the industrial might behind the Mustang. The operational decline of the P-84 was swift and brutal due to the combination of manufacturing and logistical failures. Attrition rates soared, but not only from combat losses inflicted by the superior P-51 Mustangs and Hellcats. More P-84s were lost or grounded due to engine failures, structural collapses, and landing gear breakages than to enemy fire. By the end of 1944, Japanese air units reported that their P-84 readiness rate was often in the single digits. A squadron of 20 fighters might be lucky to put 2 or 3 operational aircraft into the air on any given day. This meant the Hay-8 could never be deployed in the mass numbers required to effectively counter the massive Allied formations. The precious few flyable aircraft were frequently flown by exhausted, poorly trained pilots rushing to defend against overwhelming odds. As the war entered its final year, the P-84 became a symbol of national desperation, a high-performance plane waiting for a spare part. Ground crews grew demoralized by the endless, frustrating work of trying to repair engines with inadequate tools and no replacement parts. The intended war winner was reduced to a sporadic annoyance for the Americans, not a serious strategic threat. The decline of the P-84 mirrored the overall decline of the entire Japanese war machine as the pressure became too great. In the final, desperate phase of the war, the P-84 was tasked with the near-impossible mission of defending the Japanese home islands. Its primary target became the high-flying formations of American B-29 Superfortress bombers on their destructive runs to Tokyo and other cities. This proved to be the Hay-8's final and most frustrating challenge, due to the B-29's cruising altitude. The Superfortress flew at heights where the Homar engine of the P-84 was operating at the very limit of its performance envelope. Pilots struggled to even climb to the required altitude, and once there, their engines ran rough and their speed was significantly reduced. Even the fully armed P-84 found it extremely difficult to inflict decisive damage on the heavily armored B-29s. The Japanese pilots had to rely on dangerous head-on attacks or, in some cases, the desperate tactic of ramming the bombers. These final intercept missions were often flown by teenage pilots with minimal training, adding to the grim toll of attrition. The P-51 Mustang escorts became the gatekeepers, mercilessly sweeping the skies clear of the struggling Honots before they could reach the B-29s. For the few remaining veteran Ki-84 pilots, these final battles were a hopeless, heroic stand against insurmountable technical and numerical superiority. The Ki-84's final role was a testament to the courage of its pilots, but a final indictment of its unreliable engine and support. The story of the Nakajima Ki-84 H-8 is a tragic case study in the perils of wartime overambition and industrial collapse. It was an aircraft that possessed all the theoretical ingredients of a world-class, war-winning fighter. Its engineers successfully created a highly potent blend of speed, maneuverability, and firepower that briefly stunned the Allies. Yet, its magnificent design was betrayed at every turn by the very infrastructure that was supposed to support it. The unreliable Homar engine, the lack of quality fuel, and the inferior manufacturing meant its potential was never realized. Only a small fraction of the 3,500 Ki-84s produced ever truly flew at their intended, full performance capabilities. It was a machine that showcased the extraordinary talent of Japanese design, a final, brilliant flash of ingenuity against the darkness. Ultimately, the Ki-84 was not defeated by a fundamental design flaw but by the Mustang's reliable industrial foundation. The P-51 represented the overwhelming, reliable output of the American arsenal of democracy. The Frank was a phenomenal idea, but the Mustang was a phenomenal reality, mass-produced to perfection. The H-8 remains one of the greatest fighters to emerge from the Axis powers, yet one that was perpetually crippled. It stands as a poignant symbol of a great technological design that was ultimately torn apart by the realities of a total war.